everyone, I am Imran, Faculty of the Mathematics, Ravindra Bharati Education Institution, Corelating, Tumkur District, Karnataka State. In the first video, I had discussed about the Vedic mathematician and about their contribution and about their treatise, that what they had written. And now today I am going to present one of the most amazing concept. See, this concept is highly related both for algebra, arithmetic and also the geometry. I think you already heard about the great mathematician, Greek mathematician, Pythagoras. Today I am going to take Pythagoras Theorem. But you don't think about just I am going to deal about the geometry. I am going to correlate both the algebra, geometry and arithmetic. Okay, my dear students, it is one of the most interesting topic. See, proving the Pythagoras theorem have the lots of method, but today I am going to introduce you one of the most wonderful method. Even a fickle-minded student can also do this. That's why I before only told you my classes are going to arouse one of the most interest in you people and develop certain enthusiasms and develop certain interest in you people to motivate towards the mathematics. See, this theorem is very interesting not only for the students and even for those people who learn mathematics in their beginning level. Somebody told mathematics is a cut and grit subject, but in my view, mathematics is not a cut and grit subject. It is a very spongy and the puffy, because to go through to solve the problems, there are the various ways are there, not only a single door. You can able to go with various doors. That's I'm talking about the various method and strategy. Each and every problem in the mathematics can be solved in their own way. See, that's why the Pythagoras theorem had been proved in a certain methods, in a various methods. Even Einstein had proved that one, Pythagoras had proved that one, Baudhayana had proved that one in their different ways, and so many of the modern mathematicians also had proven. Totally there are 200 to 300 methods are there in proving the Pythagoras theorem, but today I am going to show you the most easiest method. Just I am correlating the identity of the algebra and the equation of the geometry, and afterwards I am applying to solve the problems in the arithmetic. Okay, my dear students, see, what are the basic fundamental identity of the algebra? Do you know? We have the fundamental identity a plus b whole square is equal to a square plus 2ab plus b square. On the other side, we have an equation that is a square plus b square is equal to c square. Okay. What does that a plus b whole square is equal to a square plus 2ab plus b square indicates? In the arithmetic that we are going to solve various type of the problems, especially in the square and the square roots. But this a square plus b square is equal to c square. What does it represent? Of course, I think you are already thinking about this, as this indicates the Pythagoras theorem. Do you know what does the Pythagoras theorem states? I will tell you. See, if for example say a and b are the sides of a right angle triangle and c is the hypotenuse of the right angle triangle, then the Pythagoras theorem states that the square of the hypotenuse is equal to sum of the squares of the other two sides. Geometrically, I will write here, if this is a right angle triangle, if these are the sides of the right angle triangle, this will become a, this will become b, and this will become c. That's why I am telling a square plus b square is equal to c square. It is nothing but the square of the hypotenuse is equal to sum of the squares of the other two sides. See how this algebraic formula is totally related to this equation. I will give geometrically about this. Okay, dear students. Now I am just going to take one simple figure. I am not going to take any exact measurement. In the algebra, if there is no any exact measurement, we are calling that is an arbitrary measurement I am going to taking. See, just I am going to draw one line here. In this line, I am going to divide this line by putting one point here. See, from here to here, consider the length is a. From here to here, consider the length is b. With the same dimension, with the same length, I am going to draw a square. Now just to see here. Again, I am taking this as length a and this as length b. For making a square, again I am drawing one line here. Again I am taking this length a and this length b. Now complete the square. This is length A and this is length B. Okay, whatever the points are here, I am going to join those points. Therefore, see here, this one, join this one and join this one. In this whole square, again another one square has formed. Okay, therefore I will take the length of this sides of the small square is C. This is C, this is also C, and this is also C. Students, you just see the figure. Here, there are the four right angles are there. One big square is there. In that, one small square is there. Now, you please remember what are the formula for the area of the square and area of the triangle. This is not a difficult task for you because you already, if you are studying in the secondary students means, then definitely you have that much of the knowledge. Okay, I will tell that. What is the formula for the area of the triangle? Area of the triangle is equal to half into base into height. Okay, see in this right angle triangle, which is the base? A is the base and B is the height. Okay, now what is the area of the square? Area of the square is nothing but side into side, this side and this side. Okay, therefore the area of the bigger square, you just multiply the sides, that is A plus B. What is A plus B? Is the length of one side again into A plus B. A plus B into A plus B. That is A plus B is into A plus B, which is equal to A plus B whole square. Now I am taking the area of this big square. What is the area of this big square? Nothing but area of the big square is equal to area of the four right angle triangles plus area of the small square. Okay, that is area of the big square A plus B whole square, which is equal to area of the four right angle triangles, that is 4 into half into what is base A, what is height B, plus what is the area of the small square? C into C, side into side, which is equal to C square. Okay, see here, 2 1s are 2 2s are. Okay, that is A plus B whole square, which is equal to 2AB plus C square. What is the expansion of A plus B whole square? A square plus 2AB plus B square, which is equal to 2AB plus C square. See, you just go to the axioms. What does the third axiom says? If equals are subtracted from the equals, the remainders are equal. That is 2AB get cancelled on both the LHS and RHS. The remaining A square plus B square is equal to C square. This is the Pythagoras theorem. Dear students, we just proved the Pythagoras theorem by correlating algebra to the geometry. Now you are thinking how that we have to correlate to the arithmetic. See, what does the Pythagoras theorem says? A square plus B square is equal to C square, where A, B, C are the sides of the right angle triangle. If you will give certain values to these sides of the triangle, then you just check whether those values are satisfied or not. I will give the three values. See, let A is equal to 3, B is equal to 4, C is equal to 5. Let us check whether it will satisfy or not. See, 3 square plus 4 square is equal to 5 square. What is 3 square? 9. What is 4 square? 16. What is 5 square? 25. 9 plus 16, 25 is equal to 25. If these values satisfy, then 3, 4, 5 should be considered as Pythagorean triplets. I will give the assignment. Some more triplets are there in the natural numbers. You please go and check and just put me in the comment box which are the other Pythagorean triplets are there. Now my question is 3, 4, 5 is the natural numbers. These are the natural numbers which satisfies the Pythagoras theorem. Now My question is whether irrational numbers also there, they will satisfy the Pythagoras theorem or not. This is one of the confusion will arise in every student. I will take some more values, some irrational numbers also there, they also satisfy the Pythagoras theorem. For example, say certain irrational numbers are there. I am going to prove the Pythagoras theorem will satisfy for those irrational numbers also. Dear student, you just see here again a square plus b square equals c square. I am taking certain irrational number. Let a equals root 3, b equals root 5, c equals root 8. Substitute these values in the Pythagoras theorem equation, that is root 3 whole square plus root 5 whole square equals root 8 whole square. Basically in the simplification, you know very well, the square and the square root get cancelled. Okay, the remaining 3 plus 5 equals 8, that is 3 plus 5, 8 equals 8. This was the Pythagoras theorem had shown. It will satisfy both for the rational and irrational numbers, and the numbers which will satisfy the Pythagoras theorem are surely called the Pythagorean triplets. I hope this video will highly impress you. If you will impress, have learned something, my dear students, don't forget. And before that, I will tell one most important thing to you. The method we just solved came from the China before 2000 years by correlating algebra to the geometry and arithmetic. Okay, my dear student, don't fear, though it is came from the China, good things can be copied. Please like, share and subscribe to my video, and you wait for certain more videos. I will solve very simply, and I will use very good strategies to make you to arouse your interest in the mathematics. Thank you very much.